Okay, today, well, actually not today, but for the rest of the chapter, we're going to follow, for the most part, the same procedure, and that is going to be looking at a lot of the shapes that we've talked about and calculating areas. Okay, so for today, we're going to talk about triangles. Now, that seems easy. We've done area of a triangle before, right? Right. Okay, so for instance, find the area of that triangle. Aiden, you got one right there?
Yeah.
Okay. Go.
45.5.
Can I get a confirmation, please?
Yeah.
45.5. Beautiful. Aiden, how'd you do that?
13 times 7 divided by 2.
Beautiful. 1/2 base times height. General formula for a triangle. Okay. A right triangle. Oh, couldn't have planned that better myself. For those of you that didn't hear Jane, she just said for a right triangle. So true. 13 times 7 times 1/2 gives us, I forget what you said, 45.5?
Yeah.
What are my units here, Aiden? Good. So then what do you use? If I didn't give you units, what do you use for units?
Unit squared.
Unit squared. Very good. Okay, so if they're centimeters, centimeter squared. If they're meters, meter squared. We've done this already. This is not new. What's going to change, however, is what if it's not a right triangle? Okay, so this is going to get a little crazy. 3 different scenarios. We'll start with the first one. Okay, so I got a triangle. Wait a second. Let me change that a little bit. I want to bring that over there and bring it down here. Okay. So I've got this triangle. For this particular triangle, I can find the area of this triangle 3 different ways. The formula that we just used still applies. 1/2 base times height. But a formula without understanding gets you nowhere. What's different about this triangle is that it's not a right triangle. And so we have to figure out how do the base and the height interact. So I'm going to start by making this, whoops, I'm going to make a mistake. Sorry, let me try that again. I'm going to make that the first base. If that's the base, I need to know where the height is. And always in a triangle, the height should be perpendicular to the base. Okay, so there's my height. Okay, so let me say that again. The height should always be perpendicular to the base. When we go back to this triangle, that's not a problem. The height is automatically perpendicular to the base because we've got a right triangle. Easy peasy lemon squeezy. However, when we got something like that, it makes our lives a little bit difficult. Unless, of course, it's just a simple problem where I give you the base, I gave you the height, and we go with it. Okay? However, this triangle, I can also find the area using a couple different methods. I could, for instance, let's go there and then change this to the same blue. I could make this the base. And in fact, I'll call that B2, different base. Spin the triangle around if you want. I'm not going to spin it around, but you could. I'm going to make that the base. And then my height would come from this vertex. Okay, bad move. There we go, that's better. Perpendicular to the base again. So there's H2. Question?
Would you this is just kind of a guess, but would you do that with all the sides and then divide it by 3 and get the average of them?
Doesn't have to be that difficult.
Okay.
I'm just showing you different ways that you could do it. If I knew the values in the purple, I would just use the purple 1/2 base times height, calculate it. But I'm showing you the other ways. Okay. Then the third way, in a lovely shade of green, and I'm sure that many of you are good at pattern recognition, this would be the third base, and then my height would be this. H 3. Okay. So depending on what, wait a second. Bonus question. Woo, woo, woo. What's special about that point?
Oh,
Which one is it? Rumps?
is it the perpendicular bisector?
No. 1 down, 3 to go. Zoomers, anybody? Which center is that? Yeah.
Circumcenter?
Say again?
Circumcenter, I think?
No, it is not the circumcenter. That would be the perpendicular bisectors. We're getting closer. I know it was so long ago. Go. Round 2.
Orthocenter?
It is the orthocenter. Woohoo! Completely irrelevant to what we're doing, but I just thought I'd throw that in there for a trivia fact. We are never going to calculate an area by using all 3 of those things. Okay. But that's where it comes from. And the important thing to notice is, in fact, it's so important I'm going to write it down. The height must be perpendicular to the base. Regardless of what the triangle looks like. Sometimes, like in a right triangle, that will take care of itself. In a non-right triangle, it's not so easy. Questions so far? Okay, let's start with something simple. Okay, let's make this 13. Let's make this guy. All right. Ten. What's the area? Don't be bashful. Give me an answer. Go, Nico.
65.
Confirmation? Yeah, affirmative. 65. I'm assuming, 65 what?
Unit squared.
Attaboy. I'm assuming you did 13 times 10 times a half.
Yeah.
Good. Okay, let's change the problem. Let's get rid of that. Let's change the color into pink. Get rid of that problem. And suppose the area is 256 centimeters squared. How long's the base? While you're calculating that, I'm going to talk a little bit. If we go back to the original formula that Aiden gave us, 1/2 base times height equaling the area, there's 3 variables there. There's the area, there's the base, and the height. You should be prepared to solve for any one of the 3 given the other 2. So the first example that Nico just did, we took the base times the height times a half and solved for the area. This one, I'm giving you the height, I'm giving you the area, and now you solve for the base, and Aiden has an answer.
I think it's 51.2.
51.2. Affirmative? Beautiful. Area is equal to 1/2 base times height. So 256 is equal to 1/2 b times 10. And I'm assuming you did, what did you say, 51.2
51.2.
units?
Squared. Unit squared. Oh, centimeter squared. I didn't see. Yeah, centimeter squared. Yeah. No. Oh, no, it's just centimeters, not squared.
I knew you'd get there eventually if I just stared at you long enough. Good. Because again, that's a linear measurement, so no units.
Yeah.
Okay? Good. Problems? Awesome. Very seldomly are you going to see a problem like the first one where I just give you the base and height and have you plug and chug? Because, I mean, a fourth grader could do that. We're looking for something a little bit more interesting. Questions so far? No? Zoomers, good? You with me? Yeah. Okay, great. Let's move on. Little bit of review here. We'll take a break for a second and do a review. We've done this before. You just don't remember it. What if it's an equilateral triangle? S, S, and S. Brooke, how big are the angles in that equilateral triangle?
60.
Beautiful. 60, 60, and 60. Because it's equilateral and it's equiangular, or 180 divided by 3 is 60. Great. Okay. And we've gone through, or I should say, I've gone through this whole derivation before, so I'm going to be very brief with it. If I draw this height, let's get rid of the 60 there. That's in my way. Brooke, back to you. How big is that angle? Beautiful. Almost done with you, Brooke. How long is that?
I'm not sure.
Jake.
Half of S.
Half of S. Very good. And way back when we talked about equilateral triangles, we did the Pythagorean theorem to solve for the height, and then we put that together into a formula. And I'm not going to do that whole thing again. I am going to remind you that the area of that equilateral triangle is equal to S squared square roots of 3 over 4. Okay. Now, if you don't want to use that formula for an equilateral triangle, that's okay. You can go through the same process we just did here. Or you can plug and chug. But again, a formula without an understanding of what's going on is a waste of time. Go.
Where did you get, like, are the 3 and the 4 part of the formula?
Yes.
Okay.
Yeah. And those come from solving the Pythagorean theorem to find out what the height would be.
Okay.
This is actually 1/2 base times height with this funky height that we get when we solve Pythagorean theorem.
Okay.
Okay, so let's get rid of this, and we'll do 2 examples with this problem. We'll start with the first one. Get rid of that guy. And we'll do an easy one first. If that's 7, what's the area? Decimal equivalent is fine. You don't need to leave the square root in there. That makes no sense. I mean, it does make sense. It's just nobody's really going to talk that way in the world. Hello.
21 point.
Can I get a confirmation? Yes? Beautiful. How'd you get that? Plug and chug, right? Okay, good. Now, could have gone through the other method and said, okay, well, here's the height, and then this is 3.5, and do Pythagorean theorem to find the height, then do 1/2 7 times whatever height is. But if you just plug and chug here, we get 49 square roots of 3 over 4, which plugged into the calculator, would you say 21.22 units squared. Okay, questions? We're good so far? Okay, let's make it more interesting. Let's get rid of this mess. We'll shrink this a little bit, move this up in the corner, and let's suppose we know it's still an equilateral triangle, and I know the area of this triangle is 1,000 millimeters squared. How long is the side? Time to run with the big dogs, kids. Come off the porch. Let me get this out of the way so it's not confusing anybody. And again, I'm going to continue to talk while you're calculating. When we did 1/2 base times height, there were 3 variables there. 3 different types of problems. With this formula, there's only 2 variables, the area or the side length. The first one we did in yellow was given the side length, solve for the area. This is going backwards. Given the area, solve for the side length. Zoomers, anybody want to contribute here? Or not? Am I muted? No, I'm not muted. Ella, go. 189.74. Confirmation, anybody? Okay, so are you not confirming because you got a different answer, or you have no idea what's going on? Which one is it?
I don't know what's going on.
You don't know what's going on. Not know what's going on?
A little bit.
Not know what's going on?
I got a different answer.
You did? What'd you get?
I got,
Let's have an answer off.
I got 48.
48 exactly.
Was
Some decimals afterwards. Okay. You what?
I got the same.
You got 48 also? Uh-oh. Well, I don't know. We'll see. Maybe you both made the same mistake and Ella's right, or maybe Ella's wiggity wiggity whacked in the immortal words of Criss Cross. Criss Cross will make you jump, jump. Mac Daddy make. Anybody? Criss Cross? You guys know Criss Cross?
I know the song that you're talking
Yeah,
about.
but you don't know who those 2 little punks were?
I think I might.
Like 12-year-olds wore their clothes backwards?
No.
Yeah, that was their gig. They wore their clothes backwards and then sang happy rap songs. It was a travesty, a low point in American culture. Colin, what'd you do?
I just plugged it in and solved.
Okay, so let's talk about that whole solve thing because I think some people are struggling. What'd you do first?
Did that. Oh, I took 1,000 and divided that by 4. Or multiplied it by 4.
Oh, there we go. That's better. I knew you'd get there eventually. Okay, what's next?
Then I divided by the square root of 3.
And I'm assuming at this point in time you're doing this on your calculator. Okay, so that cancels. Last step?
And I got the square root of
Good. Like I said, he probably did it on his calculator. Not that I don't trust you guys, but let me confirm here. Square root of 4,000 divided by the square root of 3, close parentheses, 48.056. Nicely done. Approximately 48.1 millimeters. Okay. Good. Being able to work that problem backwards. Okay. Questions? Lovely. Okay, so reviewing so far. I got one more thing to show you. Right triangle. Not worth our time. We've done that so many times. In Latin, it would be ad nauseum till you puke. Regular plain old triangles. Have to remember the height must always be perpendicular to the base. Along the lines here, let me draw you one more picture just to freak some of you out. If you have a triangle, hold on, let me shrink this. Put that up there. Whoops. Nope, that was a mistake. Let's take the whole thing. Okay. What if you have a triangle like this? An obtuse triangle. This causes problems and bothers people. obviously there's our base. Where's the height? Well, if you look in red, it said the height must be perpendicular to the base. How do I go from this point and end up perpendicular to the base? The answer is I can't. So I cheat. How do I cheat? I come over here and I do this. That becomes my height. Now wait a second, that's not perpendicular to the base. It is if we extend the base. Lily, how many triangles in that picture? Nope. No. Nora, how many triangles in that picture I just drew? Three, correct. The right triangle, the little right triangle, the obtuse triangle, and then the big triangle that goes around that. So, giving you options, if I asked you to find the area of this blue triangle, you could do it a couple different ways. Okay, one would be, well, base times height times a half, we're done. However, we could also use the subtractive method. You could find the area of this big honking triangle, which is a right triangle, and again, assuming you had all the measurements. Then you could find the area of this smaller right triangle, and then subtract. And you'll recall we talked about the additive method and the subtractive method. So a couple different options. The obtuse triangle is the one that freaks people out the most. But again, we'll go slow with that and you'll get that all worked out. Okay, so height must always be perpendicular to base regardless of the shape of the triangle. Then practice, practice. Equilateral triangle, special type of triangle. And now the new one, and this is one of my favorites. What if we have a limited amount of information on a triangle? So let's take this triangle. Okay. And I know that this is 13, this is 24, and I happen to know that angle. Okay, so let's make that angle, I don't know, 37 degrees. There's a nice, pretty little formula that we're going to use a lot to find the area of that triangle. Now, if you look at that triangle initially, you would think to yourself, I don't know how to find the area of that triangle. Because what chunk of information I'm missing is I don't have this height. Joey,
Yeah.
could you find that height?
Could you use law of sines to find it?
Beautiful. Yes. So we could go and calculate this height, right? Law of sines, right triangle trig, the sine of 90 over 13 is equal to the sine of 37 over h. Then all of a sudden we have the height, we have the base, we go back to 1/2 base times height. Okay? That's one method. However, if we do this for a general triangle, so I'll come back to the numbers in a second. Let me get rid of these. Get rid of all this mess. And this guy. Oops, is that the triangle or is that? No, I just want that. Give me that. There we go. Okay. Hold on, we're experiencing technical difficulties. Okay, so let's suppose I knew this side, we'll call it A. I knew this side, we'll call it B. And I know the angle, which we'll call theta. We've talked about the Greek letters already, haven't we? So that's a theta. And that's the same scenario we just looked at, commonly called a side angle side scenario. Again, we could go back and do the method that Joey talked us through. However, there's a nice, pretty little formula here which says the following: 1/2 AB sine theta. If you know two sides of a triangle and the angle in between the sides, you can find the area by applying that formula. Where did that formula come from? That formula came from the exact method that Joey just described by finding the height and doing some work. Okay? So we're going to save all that work and that derivation and go right to that formula. Okay, so let's put the measurements back. If I remember correctly, this was 24, this was 13, thank you, and I believe the angle was 37.
Yeah.
Good, find the area. Marcus, what do you got? Let's give him a shot. Do you have a calculator? Well, therein lies the problem. Uh-huh. Jane,
I got 93.89.
hold on. Aiden, you don't have, well, did you have an answer?
No, I was.
Oh, I thought you raised your hand.
No.
Sorry, I didn't mean to put you on the spot. You gonna be okay?
Yeah.
Okay, good. You don't need to see a counselor or anything? Okay, good. Can I get a confirmation on 93 point?
0.89.
Good? Good. Okay, plug and chug. So Jane, I'm assuming you did 1/2 24 times 13 times the sine of 37.
Yeah.
And got 90, okay,
93.89.
Awesome.
Units squared.
Units squared. Well done. Okay, questions for Jane on that one? Awesome. Let's make it more interesting, shall we? Get rid of that. Get rid of that. And then we'll leave that there. Okay, here we go. Time to come off the porch. This is 10. This is 7. And the area is, hold on, I don't want to guess. Let me, hold please. And the area is 30 centimeters squared. Solve for theta. want people getting stuck on the same point. So when you have this number, don't use that, use the whole thing that you got. Got it? Hard to get. Sure, it's not division, it's multiplication. Let's divide both sides by 3. Okay. Colin, tell us what you got.
I got like
59 about. Okay. And Brooke, you were close, right? 59. So you had like 58.99
Yeah.
and you had 59.62. Okay, so let's talk a little bit about the rounding here. First of all, let's go through the solution. Still a matter of plug and chug. So 30 is equal to 1/2 times 10 times 7 times the sine of theta. Walking around the room here, I don't know about you Zoomers, but walking around the room here, most people were able to get to a certain point and then the wheels fell off the bus. Okay, so I'm guessing that most of you were able to get to 30 divided by 35 is equal to the sine of theta. If you prefer 6/7, but we don't care, you don't have to reduce it. Now, how do I get theta by itself? Go.
Well, I kind of did it a different way. I did like, it's like after I got 35, I said 30 equals 35 sine of theta, and then I divided it by 35 sine. But I got 52.3, everyone else got 59. So.
Yeah, because you gotta leave the sign over there by itself.
Oh, right.
Okay, Brooke,
You take the negative sign of both sides.
good. Technically speaking, the inverse sign, but yeah. Take the inverse sign of both sides. The inverse sign and the sign will cancel each other. That leaves theta on one side. And for those of you that were off a little bit, you want to plug in an exact value. So if you take 30 divided by 35, 30 divided by 35 is equal to 0.857142857. If you just round that off or chop part of it off and plug it into the inverse sign, it's going to create an error. So you want to use either this, and you can do that on your calculator, inverse sign of 30 divided by 35, close parentheses, or store the number when you divide it. And when you undo that, using the inverse sign of that gives us, as Colin said, 58.99, which would be 59 degrees. Okay. Each one of these problems, each one of these scenarios has different ways to solve. The first one we did here was easy because it's just a plug and chug. 1/2 times the numbers times the sine of the angle. It gets a little bit more complicated when you're asked to go backwards. A little bit of a algebra review on how to get those values by itself. Okay, remember, undoing the sign is the same thing as getting rid of, or is the thing you use to get rid of that sign. Okay? We're going to use this formula a lot in the next couple days because we're going to transition from triangles to regular polygons, which doesn't seem like that's a logical approach, but it is. You'll see why in the next couple days. It would seem like we would go triangles, then quadrilaterals, then regular polygons, but again, you'll understand when we get to the regular polygons on Thursday why we're going in that order. Okay? Questions on any of those? Again, if you just copy down these formulas and just plug and chug blindly into the formulas, you're going to struggle because you're not going to understand what you're doing. So it's important to understand, Gesundheit, how you solve each of these. 1/2 base times height, s squared squared to 3/4, and 1/2 AB sine theta. And the other nice thing is there are numerous ways to solve each of these problems, depending on what approach you want to take. Okay? Questions good? Zoomers, questions? Beautiful. All right, let me stop my recording.